Hey, this is Mr. Wyrick. A little bit of a change of plans this morning. Had some illness at my house, so I'm not going to be there today. There's not going to be a Zoom, so if we're going over the review, I don't have a paper copy of it, so this is going to be interesting. But I'm making this video, and I'm going to maybe walk you through the computer version that I had, and then I'll try to get a key posted later today so that you can see that as well. So here on the first page, this whole first page is just a formula chart, formula sheet, it says. I apologize for it being in Comic Sans. Over here on the trapezoid, remember that's half of the height times base 1 plus base 2. Usually when I've talked to you before about that, it's the two bases. That's the opposite sides that are parallel. I say you just average those together. So I always think of it as the 1/2 base 1 plus base 2, half of those two bases added together, multiplied by the height. So it's kind of like you're making a rectangle out of it, but however you want to put the formula together, that works. Remember the regular polygon down there at the bottom, it's the area is 1/2 the apothem times the perimeter. And it does have a key of what all these letters mean. Down here at the bottom with the formulas on these 3D shapes, it's important to remember that unlike some of these surface area ones, the volume ones as well, that capital B is the area of the base. So on the one where they have the pyramid, the area of that base would be that rectangular or square base. You would find that, multiply it by the height, and then multiply by 1/3. That weird cursive L, that's the slant height. The capital P is the perimeter of the base. So when you have one of these weird pentagonal prisms, then that's what you're dealing with. Remember the lateral surface area too is just around. Also, I mean, these are the formulas. This is how it breaks down. But you can also just say, okay, what would happen if I made a net out of this? If I folded this out into its separate parts, what kind of work would I be able to do there? So that's what we're looking at for those. On number one, if you were to cut each of these 3D shapes in various ways, what would the cross section look like? And I gave the examples of horizontal and vertical underneath the shape. So that first one, the cone, if you're cutting that cone horizontally, you are going to get different sizes of circles. They will be similar to that circular base, but you're just going to get those circles. If you cut it vertically, though, you can kind of imagine looking at it straight on from the side, all of those cross sections are going to be triangles. If you look at the sphere next to it, no matter how you cut that sphere, you're going to end up with circles, and they're all going to be similar to the circle that would be kind of around the center, like the equator type of this sphere. On the third one, the rectangular prism, there's plenty of different ways that you can cut that one. It's a weird shape. So as we cut like on one side, however you cut it vertically, horizontally, or across coming down in 3D, what you're looking at is you're going to have a similar shape to each one of those bases. So all three of them are different rectangles. So those are the rectangles that are going to be represented there. On the last one, it is a hexagonal based pyramid. So if you cut it horizontally, you're going to get smaller and smaller hexagons as you slice, and then you're going to end up with triangles if you're cutting it up and down. Maybe some weird triangles, but it's just going to be triangles. On the next one down, on the first grid, if you put 0, 0, 3, 0, 3, 4, and 0, 4, you have a rectangle. Okay, and if you rotate it around the y-axis, you're moving it around like this. Well, if you take a rectangle and move it around in a circle, you are going to end up with a cylinder. And it's going to be a cylinder that has a radius equal to the distance from the center to the outside. So this is going to be a cylinder with a radius of 3, and it will be in 3 dimensions. Okay, on the second grid, the 0, 3, the 3, 0, the 0, 0, that one, when you rotate it around, is going to be a cone. So we're looking at a cone for that one there. Question number 3, Fred is building a house of Legos that are all the same size. His rectangular design calls for one side to be 4 blocks long, another side to be 7 blocks long. He has extra blocks and plans to triple the side lengths. What will happen to the area? What about the perimeter? So 4 times 3 would be 12. 7 times 3 would be 21. So those would be the new side lengths that would happen. If all we're doing is tripling the side lengths, then the perimeter, the last part of the question, is also going to be tripled. The perimeter works in the same vein that just scaling up the sides does. The area, however, since we're tripling this side and tripling this side, the area is going to be 9 times as large. Remember, we've got to raise it to that exponent. Number 4, Sam is going to paint a cool design on his Rubik's Cube. If the sides are all 3 inches, how much paint coverage will he need? A Rubik's Cube is a cube. So this side is 3, this side is 3, that's 9. And we're talking about surface area here because we're painting on the outside. We're not filling it up with paint. So 3 by 3 is 9. Each side is going to be 9 square inches. And there are 6 of those faces on a Rubik's Cube or any cube. So 9 times 6 is going to be 54 square inches. Number 5, Sam decides to visit restaurants and stores and surprise them by painting the inside of every roll of toilet paper bright green. If the tube has an opening of 3 inches and is 6 inches long, how much coverage will be needed for each roll? I would probably need my calculator for this one, and I don't have it for this video. The opening is 3 inches, so you have to cut that in half because you need radius. Oh, no, wait, this is another surface area one. Okay, we would take pi times the diameter, and that diameter is 3. So we have 3 pi, and then we're going to multiply it by the height, which is 6. So this is going to be 18 pi. Now, 18 pi is not particularly helpful if you're trying to figure out how much coverage. But depending on how the answer is supposed to look, 18 pi would be a good one. If you need one that's decimalized, it's going to be a little over 54 because 18 times just 3 would be 54. And that would be square inches. Again, this is we're talking about surface area. Number 6, the astronomy class has a globe in the room with a diameter of 27 inches. What is the surface area of that globe in terms of pi? If it has a diameter of 27, that means we're going half of that for the radius. Okay, so half of 27 is going to be 13 and a half. And our surface area of a sphere is 4 times pi times the radius squared. So you are going to square 13 and a half and then multiply it by 4 and then multiply that by pi. Again, I'm not entirely sure I would need my calculator. I'm going to try to get a key posted for you later, but that's how you would work your way through that problem. Number 7, Bob digs a hole in his backyard and piles the dirt up into a cone. The cone of dirt has a radius of 3 feet and measures 18 inches high. What is the approximate volume of the hole to 2 decimal places? So on this one, 3 squared is going to be 9. 9 times pi is 9 pi. We multiply that by 18, and that would be 162. And then we're going to divide that by 3 because it's a cone. So that's going to take us back to 54, and it's 54 pi. So again, it's going to be like close to 162 and some change because 54 times 3 would be 162. Okay. Susie has a new Bluetooth speaker that is cylindrical. Looks like it can, standing up. The volume is 252 pi square inches. That should be cubic inches. And the height is 7 inches. What is the diameter of the base? I'm going to make that change right now to the digital one. 3 cubic inches. That would be better. And the height is 7 inches. What is the diameter of the base? So there's a little bit of work we have to do here. We're going to have to take 252 and divide it by 7 and divide by pi. So we're going to knock that pi out of there. 252 divided by 7 is going to be 36. And that would be my radius squared. So to get just my radius, I take the square root of 36. I get 6. And it's asking for the diameter. So 6 times 2 is going to give me 12 in this case. Number 9, Sarah's making a cake that looks like the castle tower shown above. It's a cylinder and it's got a cone on the top. The radius of the cylinder is 3 inches. The radius of the cone on the top is 1.5. The total height of the tower is 15 inches and the cone makes up 4 inches of that height. What is the total volume of the cake? So we're doing pi r squared times the height for the cylinder. So 3 squared is 9 times just the height of the cylinder, which would be 11, is 99 times pi. So 99 pi, or, 292 and some change if you decimalize it. And then the cone, 1.5 squared, I'm not real sure what 1.5 squared is. It's going to be somewhere between 1 and 4, I know that. So you'd take 1.5 squared. Again, you'd multiply by pi. You'd multiply that by 4 because that's the height. And then you have to multiply by 1/3 or just divide by 3 because that is a cone. And then you'll add those two shapes together. Hopefully that gets you where you're going on that one. Again, I'll try to post a key. Number 10, Stephen is an architect and is making a 1/32 scale drawing of the building. If the walls are 2 feet high on the drawing, how tall is the real thing? Well, 2 feet high times 32 would be 64, so the walls would be 64 feet high. If the same wall has an area of 6 feet on the drawing, what is the area? Okay, so 1/32, you're going to square that. Okay, it's really going to be like 64 times 96 to get the area. How would the volume compare? It's going to be 32 raised to the 3rd power. It's going to be a very large number. The volume is going to be so much bigger on that because of the way that the scale is. Okay, again, I'll try to get a key posted so that you can have the numbers. But just remember, whatever the ratio of our sides is, if we square it, that's the ratio of our areas. If we cube that ratio, that's going to be the ratio of our volumes. The pre-AP supplement questions. So if you're in on-level, you don't have to worry about these. You are making a new Mountain Dew can that will hold triple the amazing dew action, triple the volume. Which of the following ways will work? Triple the radius and keep the height, triple the height, keep the radius, triple the height and the radius, multiply the height by 6. The multiply the height by 6 is just a joke. It's not really in there for anything serious. The ones that will work, though, if you triple the radius, it will multiply the volume by 3 because we're only expanding one. Oh, no, that won't work, will it? Might not. What I would do on this one, just to make sure that you know what you're doing, is actually just put in some original, like I would draw the can. And I would say, okay, here's my original Mountain Dew can. It has a radius of 1 and a height of 2. So if it has a radius of 1 and a height of 2, 1 squared is 1 times 2 is 2 pi for the volume. So if we triple that radius, that would be 3 squared is 9 times 2 is 18. That's not going to triple the volume. If we triple the height, that would be 1 squared times 6. So that would just triple, like just the volume. Triple the height and the radius is going to make it way too big. And multiply the height by 6 is not going to work. But again, like assign numbers to it, test those numbers. That's what's going to work for you. And then Freddie is making specialty waffle cones for his ice cream shop. Each cone has a diameter of 10 centimeters and a slant height of 13. How much ice cream will it take to completely fill in the cone? So there's some work that we have to do here. If the diameter is 10 centimeters, then the radius is going to be 5. If my slant height is 13, I have a right triangle here, and it's a 5, 12, 13 right triangle. That means the height of this cone is going to be 12. So the volume of this cone is going to be 5 squared is 25. 25 times 12 is 250 plus 50, 300. So that'd be 300 pi, and then divided by 3, so 100 pi cubic centimeters, or 314 cubic centimeters to completely fill in that cone. No air, just smashing that ice cream down. It's just a volume question, just kind of phrased a little different. Make sure you understand, working out the height. And if you have the diameter, you don't need the diameter, you need the radius on that cone. Okay, again, sketching a quick picture will help you out if you're working your way through that. So hopefully this helps you get through the review. Again, I'll try to get a review, a key posted for this today. And good luck, and hopefully we'll see you tomorrow.